On the set of axes provided, sketch each of the following logarithmic graphs. Clearly label any axial intercepts with their coordinates and asymptotes with their equations. For part A, we're asked to sketch y equals log 2 of x minus 1. So the first thing we're going to consider is the transformations that have occurred. For this graph, we have the negative 1 in this position, which corresponds to a translation of 1 unit in the negative y direction. So that means that the vertical asymptote at x equals 0 remains there. So we put a red dotted line that we can put slightly to either side of the axes to indicate that that's where its position is. And we're going to label that as x equals 0 as our asymptote. And next we can go about finding our x-intercept. So we could try and find a y-intercept. So if I did try and find the y-intercept, that occurs when x equals 0. So for our rule, we would have y equals log 2 of 0 minus 1. However, that is undefined. Therefore, there's no y-intercept, which is understandable because before we talked about an asymptote existing at x equals 0, which is the y-axis. So our x-intercept, when we go to find that, is when y is equal to 0. So we want to solve the equation 0 is equal to log 2 of x minus 1. Adding 1 to both sides of this equation gives 1 is equal to log 2 of x. And we know that log 2 of 2 would equal 1. So therefore, x equals 2 is the x-intercept of the graph. So because there's no reflections occurring, our graph is still going to be in this position here, where this is the x-intercept, which is at 2, 0. And because there's not a second axial intercept, it's good practice to put another point on the graph. So we're going to consider the case if x is equal to 1. And the reason why we chose x equals 1 is it will give log 2 of 1 minus 1. And we know that log 2 of 1 or log of any base of 1 is simply equal to 0. So therefore our y value is equal to negative 1. So that will give us the coordinate down here, which is at 1, negative 1 on the graph. So that is the completed graph of y equals log 2 of x minus 1. For part B, we want to sketch y equals negative log 3 of x plus 9. Once again, we're going to start off by considering the transformations that have occurred to y equals log 3 of x to produce this new graph. So the first thing that's occurred, due to the negative sign out the front, is a reflection over the x-axis. The second thing that's occurred is this plus 9 in next to the x results in a translation of 9 units in the negative x direction. And now because of this translation of 9 units in the negative x direction, instead of having an asymptote at x equals 0, there's now going to be an asymptote at x equals negative 9. Next we need to find any axial intercepts if they exist. So the first thing we're going to do is look for the y-intercept, and that occurs when x is equal to 0 in our rule. So this will give us y equals negative log 3 of 0 plus 9. So therefore y is equal to negative log 3, and this is just 9, which can be written as 3 squared. And now one of the properties of logarithms is if we have a power here, we can bring it out the front. So this will give us y equals negative 2 times log 3 of 3. However, log 3 of 3 is simply equal to 1. So therefore, y is just equal to negative 2. Next, we're going to look for the x-intercept of our graph, which occurs when y equals 0 in our rule. So 0 is going to equal negative log 3 of x plus 9. However, to solve this efficiently, we need to recall that log a of 1 is equal to 0. So that is to say, if the thing inside the log is equal to 1, then the whole log is equal to 0. So with that in mind, we can simply say that we want x plus 9 to equal 1, and subtracting 9 from both sides will give x by itself. And that will give us x is equal to negative 8 as the x-intercept of the graph. So taking into account that we also have a reflection over the x-axis, which we discussed before, our log graph is going to look something like this. So this x-intercept occurred at negative 8, 0, and the y-intercept occurred at 0, negative 2. So that's the log graph for this question. For part C, we want to sketch the graph of y equals 2 times log 10 of negative x plus 4. So the first thing we're going to do is consider the transformations that would have occurred to y equals log 10 of x to produce this graph. So the first thing that's happened is a dilation by a factor of 2 from the x-axis, and that's because of the 2 that's multiplying the log 10. Next, there's a reflection over the y-axis, and that's because of the negative inside the log. And finally, this plus 4 in next to the x results in a translation of 4 units in the negative x direction. And it's this translation that can help us work out where the vertical asymptote is. So where the asymptote used to be at x equals 0, it's now going to be in this position, which is at x equals negative 4. Now we can go and find our x and y intercepts. So the y-intercept occurs when x is equal to 0. So this gives us y is equal to 2 times log 10 of negative 0 plus 4. Therefore, we find that y is equal to 2 times log 10, and simplifying the part inside the log, we just have negative 4. However, this is undefined because we can't have a negative value inside a log. Therefore, there's no y-intercept for this graph. Next up, we can find the x-intercept, which occurs when y equals 0 in our rule. So this gives us 0 is equal to 2 times log 10 of negative x plus 4. And to solve this efficiently, we need to recall that log a of 1 is equal to 0. Therefore, for the equation above to equal 0, we simply need negative x plus 4 to equal 1. Therefore, solving that equation for x gives x equals negative 5. And because our graph has been reflected over the y-axis, our graph's going to look something like this, where the x-intercept is going to occur at negative 5, 0, which we found before. And now because we don't have a second axial intercept on this graph, it's good practice to put another point on the graph. So we're going to consider the case if x equals negative 6, and that will give us a y value equal to 2 times log 10 of negative 6 plus 4. And that will equal 2 times log 10 of 2. So at this point here, when x is negative 6, the y value is 2 log 10 of 2. So that is the graph for part C.